Hi, welcome to Getting Started with Data Science and Microsoft Fabric, Part 2. I'm Brian Hitney, Solution Architect focused on data and analytics here at Microsoft. In Part 1, we looked at taking some of our data and building an ML model from that using Facebook's Profit, and then storing that ML model in ML Flow and generating some quick predictions, but we didn't really do anything with that data. So now in Part 2, what we want to do is look at how we can use or operationalize that model in practice. And then what we're going to do is look at building some reports. So let's start right away by looking at some of the models that we've built. Here I'm showing my screen in my workshop space, all of the models that we built. Now in Part 1, if you saw Part 1 and recall that we have our individual stock symbols. And when we built the models, we had this naming convention where we had the stock symbol. So we have the who, the I don't give a darn, and because stocks that we built models for. And we have this naming convention for the stock symbol and then stock prediction model as our naming convention. And so we built 3 different models, and they're all right here. And if I open up the because model as an example, what we'll see is in Fabric, we can examine this experiment and then all of the runs within that experiment. So essentially looking at all the different models. And we can see here that we have 5 different versions. Every time we create a new model with this name, it will generate a new version of that model. And then we can also see all of the metrics that our model logged, such as the mean absolute percent error, the root mean square error, and so on. And then also the parameters we used when building that model. And these parameters are specific to Profit. So this gives us a way that we can gauge the effectiveness of our model over time. Now, in our case, what we always want to do is we always want to use the latest model, regardless of how accurate it is. Now, in this case, if we look at version 5, this mean absolute percent error is actually really low. It's only about 6.5%. That's surprisingly low. I bet if I go back to one of these models that I generated a few weeks ago, it's probably a lot higher. Yeah, it's significantly higher, probably because I've been building a lot more data over the last few weeks. So the model's getting better over time because I have more data to look at. So one option for us is to examine the different models that we have here and then pick the best one that we would like to use. But in our case, version 5 clearly has the best mean absolute percent error. I didn't look at the root mean square error. How was that? That was 270. Yeah, it's really high compared to in version 5, 69. So this version 5 model is clearly better. But even if it weren't better, in this case, I always want to use the latest model because the stocks that we're building are highly volatile. This is our demo generator app, so there's a lot of volatility to it. So we always have to incorporate the latest data. So even if this were an old model, this generated, say, months ago, that wouldn't necessarily help me in generating a good prediction today. So we could see that we have all of these versions here. So let's jump into our notebook and fire it off. And what we'll do, I'll scroll up to the top and I'll walk through it as we run it. So we can see, obviously, we install Profit and bring in all of our libraries that we're going to use. The first thing that we're going to do is create a table, if it doesn't already exist, called stocks prediction. And you can see over here, it in fact does exist because we've been generating predictions. So this code will run, see if it exists. And what we're going to store is the predict timestamp. So what time in the future are we looking to predict a point in time? We're doing this on a per minute basis. Obviously, we could pick whatever kind of time horizon and granularity we'd like. I'm going to store the stock symbol and then 3 values for the predicted price. Y hat, as you might recall in Part 1, is the predicted price. And then we also have the lower and upper bound of Y hat that Profit has come up with. There were a whole lot of other variables that Profit can give us statistics that it can give us for a given prediction. But in this case, really what I care most about is the Y hat and lower and upper bound. So that's the only thing we're storing in our prediction table. And then finally storing a timestamp for the time that we're generating the prediction. Then we have a simple class really just to help coordinate some of these things. We need the model's URI. We need to know what symbol we're looking at and then the time that it's generated. So just a small class to kind of help store some of these things. And then we have a write predictions routine. Now we're not calling it here yet. We're just setting up the function definition, which is just called write predictions. And essentially what this is just an upsert or a merge statement on our delta table. So when we pass in the predictions that we made, we have that in a pandas data frame. And if a prediction already exists, so we would hit the when matched update, we're going to overwrite that prediction for that specific time and symbol. That's the matching criteria. We'll overwrite it with the newest generated y hat, lower, and upper values. And if the row does not exist, then we'll do an insert of that data. So we might do a prediction for 7 days, and then we could rerun this, say, maybe every 12 hours or so. So we'll be overwriting the bulk of the data with new predictions as we go. And then what we'll do is we'll get a list of our symbols. Here we're actually calling our get symbols function. Now there's a couple of different ways to do this, and by symbol we mean the stock symbol itself, and such as because, I don't give a darn who, and so on. Now there's a couple of different ways we can go about this. We can, because this is part of our workshop that we have done, we have a lakehouse component to that workshop, in which we build several dimension tables. And one of those is the dim symbol table that has all of the symbols. So we can get all of the symbols from the dim symbol table if we'd like to. We could also get that from our raw stock data, which is the landing place for all the data that's coming in from our event stream. Or we could just simply create a data frame and specify all the symbols that we would like to use when generating new predictions. So in this case, we have 8 symbols, and we'll include them all here. So we get those symbols. We have those now in a list, essentially an array. And then we call create predictions list, which what this does now, this is the important part, because we have the symbol list that we created previously, and we're going to query now MLflow. And we're going to ask it to give us all of the models that we have. So we're going to start with experiments. We're going to, and if you recall, experiments are the containers for all of our models that we have, all of our runs. So the naming convention for the experiments is the symbol name and then stock prediction. And then the models themselves is the symbol stock prediction model. So we're going to query it for each experiment for all the different stocks where the status of it is finished, and we're going to grab the most recent model, so by start time descending. Again, we could add other criteria if we'd like to. If we wanted to say, give me the best, mean absolute percent error, for example, we could do that. And then assuming that we find them, we'll add them to our prediction list, building the model URI, and then we'll use that prediction list when done. So when we run this, what you're going to see is, if you recall, we had 3 of the different stocks that were in MLflow. We had who, I don't give a darn, and because. And you can see that it found those because we print those out. So we have the model URIs for those 3 stocks. And then we got these essentially warnings that we couldn't find these any of these experiments in MLflow, and that's because they don't exist. If we took the time to build those models, then they would be found, and they do exist. So this gives us a way then to only obviously use the models that we've actually built. So now we have these 3 models in our list. And we have a function helper here called make prediction data frame. This is largely the same thing as what you'll find in Profit. There is a make future data frame that is used also for generating future dates. So this is largely just here for academic purposes. And we also then have a function called load and predict. So this is what we're about to call. We're going to loop through now the prediction list that we created. So our 3 different predictions models that we have. And then we're going to load that model. We're going to create that future data frame. And then we're going to call predict on that model with the future data frame. So we're essentially looking at creating a 7-day forecast for for each stock. And then what we want to do once we have that forecast data is we want to write those predictions into the predictions table. So we'll start this and then I'll continue talking about what we see going on. So you can see the first one that it finds, of course, in our list is the because stock. So it downloads the model, and you can see this happens pretty quickly. It's going to generate a forecast from between January 5th and the 12th, so our 7-day horizon. And once it does that, it will store that data. It'll write those predictions then into our prediction table over here. And then it will move on to the next stock, which is I don't give a darn. You can see that it's doing that now. And finally, once it's done with I don't give a darn, it will move on to the who stock. And so this should happen very quickly because fortunately, downloading and generating predictions usually only takes a few seconds. So while we're waiting for that to finish up, the next thing I have down here are just some helper methods. If I want to delete all the predictions because I'm doing some testing and whatnot, just a little helper method for that. And then finally, our query here just to select everything from the stock predictions table and sorting it by the predict time descending, so we can see the most recent predictions that we have in there. And now finally, what we'll do is we'll look at the stock prediction table. And we can see that we have all of these predictions in here for who, I don't give a darn, because, and so on, based off of the most recent predict times that we have in there. So these predictions are now stored in our table. So the next thing that we can look at is putting those to use in a Power BI report. But before we do that, what I'd like to do is take a little detour, though, into a different notebook. The concept that we set up here is this separation of concerns. In the first notebook that we looked at in part one was really about building the model. Fortunately, that's a pretty easy process with Profit because there's not a lot of feature engineering that we have to do. It's univariate. It's only looking at the price at a specific time for us to build that model. So it's a great way to learn building a simple model. But the disadvantage to that is there really isn't much point in generating predictions now after we built the model, because the model is never going to change the predictions that it gives us. So the best thing that we can do is to generate all the predictions when we build the model. And then if we need to do more predictions, generate a new model or retrain the model. That would be the best thing to do in this specific case. So what we've done in DS3, this notebook, is essentially a mashup of part 1 and 2, where what we're going to do, and I will run everything in this notebook and then just step through it, is we're going to do a lot of what we did in part 1, which is creating the model, and then we're going to call predict on it and then store all those predictions at one time. And we're not going to persist the model at all. We could put it in MLflow and do those things, but really the most important thing for us to do is use the model, get the predictions, store them, and then that's it. If we need more predictions, we'll just generate a new model. And what we could do is store those parameters and use them at another time if we'd like to. So if we have custom parameters for tuning the model, that's where we could still use MLflow. So let's go through the notebook and see what's happening. We are still using our CSV files with all of our stock history. The reason why we do that instead of using the raw stock data folder is that because this is in our lab, if you're following along and doing this, you might have this running for a few hours by the time you get to this lab, which is great to see some data in there, but it's not enough to build a model off of. So we have these CSV files that get downloaded when you run this notebook that provide enough history, a full year worth of history for you to build some accurate models. And then we'll filter it by whatever symbol we're looking to generate a model from. And we'll go down and look. Now in our get symbols method here, what I am going to do is we have a couple of different ways we can run this. I can run this by specifying a single symbol if I'd like to here, or if we have a lot of data, I can look at the entire data set of all of our history and grab all the unique symbols that are within that data. So that's what we're doing here, is we're saying, give me all the symbols that are in this data set. We'll look at the distinct values of them and then generate predictions for each one. And then we'll store those in the stocks prediction table. So as we scroll down and look, what we're going to do is we create our generated timestamps. We have a cutoff date. The purpose of the cutoff date is because we have all this data downloaded. We truncate everything that's future looking because we want this lab to be able to work for some time. And so if you're running this a month or two from now, we still want enough data in there to build an accurate model. So we delete everything that's future looking. We'll download that history, we'll read it all, we'll filter it, and then we'll create the predictions table if we need to, get our symbols list, and so on. So then we loop through all of those symbols just like we did in the previous notebook, and you can see here that we're going through and we're generating, for this case, the because stock, we're generating our models, and then we'll store those predictions. Now, one thing you may notice is this is going to take a considerable amount of time compared to the previous notebook, because we have to build the model and then generate the predictions. So this will take about 3 minutes or so per stock, so about half an hour in total to run. And then we'll do the same thing that we did before, which was get all those predicted values. Now, even though this is taking a lot longer, I should point out that 3 minutes to run to build a model is actually a pretty short amount of time, especially considering that it is using a full year's worth of data that has 1 minute granularity to that data. So there's a lot of data points for it to build a model from. So in this case, we would probably look to run this about once a day. So with these first two sections done, the next thing we'll do is look at building some reports where we can integrate some of this data. So to do that, what we'll do is I will go to our lakehouse. We'll let that prediction routine continue to run. We filter everything here but lakehouses and open up our stocks lakehouse. And what we'll look to do is start with creating a new semantic model. And I'll just call this test so I can easily find this one later on. And I'm gonna give it a little bit more of a description. We'll just call it test model. And what we want to do in this case is add our stock predictions to it. And I'm also going to add my dimension for the symbol dimension, which has information on the symbols. You'll see why when we get into the report. If you're following along with this, though, in the lab and you haven't done the Lakehouse module, it's okay to exclude dim symbol. It's just used for one of the charts to show a little bit of breakout information, but it's fine not to have it. So I'll include those two things in test model. And the next thing that we're going to look to do is build a composite model in Power BI Desktop to take in data sources from a couple of different locations. So to do that, what we'll do is we'll switch over now to Power BI Desktop and build the reports. Actually, what we'll do before that is we will quickly just set up a relationship in our semantic model between the symbol in the stock prediction and the symbol in the dimension table. And in this case, it's going to be a many-to-one relationship between the stock prediction symbol and then the dimension symbol. And we will allow this to filter in both directions. Click OK. All right, so now we have that relationship set up. We could also do this in Power BI Desktop as well if we'd like to, but presumably we might use this model in another report somewhere, so it'd be nicer to have this done here. Okay, so now we'll switch over to Power BI Desktop and build some reports. Okay, here I am in Power BI Desktop. And what we're going to do, as I mentioned, we're going to build a composite report. And to get started with that, I am going to open up the OneLake Data Hub here in Power BI Desktop. And the first thing we'll bring in is the Power BI semantic model that we just created. And by the way, Power BI semantic model is the new name for Power BI datasets, if you're wondering if that's the same thing. And we'll see test model here that we just created. So I'll go ahead and connect to it. And we should see that show up in our data pane over here. Okay, we have stock predictions and the dim symbol, which just has the symbol, the name of the company and the market that it belongs to, the stock symbol that is. So we have all that data here. Now, the other thing we want to do, the concept behind this composite report is that we would like to have some real-time information as well. So in our workshop, we have a KQL database. It is our hot path. So all of our data that's coming in for our real-time reports is in a KQL database. So we'll connect to that. That requires a direct query connection. So we'll change it to direct query. Now, we do have the data landing in our lakehouse as well. However, in the case of our lakehouse, data landing in that raw table, it's not really suited for real-time reporting. There's latency in that data landing there, but plus it's just not, you typically would want to use something like a KQL database for real-time reports. So we'll connect to the stocks DB, which is our KQL database, and then we'll see a stock history table here that has all of the real-time reports coming in from our event hub. So we'll select that and just click load. Now we saw a brief warning there telling us that because we're connecting two different data sources, there's a potential for security issues. In this case, this is all read-only anyway, so it's not really an issue, but it's something to pay attention to depending on the kinds of data sources you're connecting to when you're combining them like that. So we have that here now. And the other thing we would like to do is go under the modeling tab and we will manage relationships. And now what I'd like to do is develop a new relationship between the stock history in our KQL and our stock predictions. We could also do a relationship to the symbol dimension. However, in this case, I'm not going to do that because a lot of people who are going to be following along with this video, they might not have done the Lakehouse module, and so you wouldn't have the symbol dimension to work with. So we're going to pretend dim symbol isn't here, and we're just connecting stock history and stock predictions. So I will select stock history. We have our symbol here, and then we have our stock prediction. We have our symbol there. And in this case, we're going to do a many-to-many relationship, which is fairly new. And by the way, we'll have a cross filter of both in this. Now, many-to-many cardinality, it's fairly rare, and it's a fairly recent thing you could do in Power BI when building a composite model. And it's exactly for these kinds of situations where you've got two different data sources, but they're still related to each other. We've got the KQL hot path, and then we also have some predictions that were made in our lakehouse. They're obviously related by symbol. And if we didn't have the symbol dimension table to work with, then the only way to relate those two is through a many-to-many relationship. So we'll go ahead and set this up. Click OK. So now let's start building our reports. So similar to what we've done in earlier parts of the workshop is let's build first our real time. And what we'll do is we want to look at the price on the y-axis, our timestamp on the x-axis, and then finally the symbol will be the legend. So we should be able to see a chart here of all the different prices over time. Now, this might not display, and the reason for that is that there's too much data. We have probably the max number of rows from a KQL query, which is about 500,000. So what we'll do is some basic filtering here, and we'll say, give me everything within the last maybe 15 minutes, and apply that filter. There we go. Now this is live. This is coming in right now, and it is right here. You can see this data. Normally what we would do is have this updating every second or so. So we would see this ticking by, but for the sake of being able to build this report, I don't want this to actually be live updating. And then obviously we could clean up the titles and some of the labeling here to make it look a little nicer. The next thing we can do, this is where we'll bring in the symbol dimension, is have a little chart here, build another one that has just about the same thing. So we'll look at price on the Y, timestamp on the X, but instead of symbol as the legend, we'll look at the market instead. And then we'll do the same thing here where we'll do some basic filtering, relative time. Maybe we'll make this 1 hour, a little bit bigger of a time horizon. And so since each stock belongs to a different stock market, NASDAQ or New York Stock Exchange, then we could track those two over time as well and see how those are performing. And so if I look at the Y stock as an example, it should filter. We should have that filtering in place. If I want to see all the NASDAQ stocks, it should filter and show me the NASDAQ stocks. So we just split them up evenly, 4 in each. Okay, so that part is working, but now what about the predictions? So we will add now another line chart, and we'll make this one span the entire width here. And now let's go to our stock predictions. And for this, what we'd like to do is we'll put our predict time on the X, so similar to our timestamp. We're going to look at the Y hat value instead of price, which is essentially our predicted price, right? We'll put that on the Y, and then we'll look at the symbol for the legend. And so this should give us a pretty similar chart to what we had up here. Let me remove the filtering. There we go. And so now we could see everything that we have in our prediction table. And in a couple of cases, we could see some pretty radical adjustments that have happened. And that's usually because I was messing around with building the model and generating some predictions, and then we could see where it corrects itself. And so we'll dive into that more here in just a second. So this is a pretty big outlook, right? That goes all the way back to sometime in mid-December and then out into mid-January. So while useful, it is a little bit noisy to look at. So there's a few things we could do to kind of clean this up. The first thing I will do is on this filter, let's look at predict time. And we will set this to a relative date, maybe with, set it into is in the next 3 days, and we'll include today. So that will narrow down the time considerably. So we have today and then or over the next several days. And we can see these little bumps here are when we created new models. In fact, that's probably what's happening right now with our routine that's currently running, is generating those new models. And we'll see those adjustments all of the time. So this is a good start, but it might be helpful to put a little bit of a display helper in here. So under my advanced visualizations, we'll generate a constant x-axis line. So here you could see that we can add a line to our chart. Now, in order to support this, and we want this to be dynamic, we want to be able to use a formula. So in order to do that, before we go any further here, in order to support the formula, what we'd like to do is create a new measure. And so under my stock prediction table, click the ellipsis there and say new measure. And essentially we can create a calculated column, use some kind of DAX expression. This one's going to be really simple. You can see that it comes up here where measure equals. So we're going to just rename this. We're going to call it current date, or cur date is equal to, and then we'll just make this now. So whatever the current time is right now, that's what it's going to be. Okay, so we have our new cur date measure. And for the constant line, we have the formula, the conditional formatting button here. And I'm going to click that, and I'm going to tell it to use the measure that we just created. And so what's going to happen when we do that is you can see it drew this dotted line here. So this is right now. This is right now as it's happening, and this will update as our chart updates with whatever time it happens to be. And then in order to make this stand out a little bit more, we could enable the shade area to be before, and perhaps bump up this transparency to something like maybe, I don't know, 80% or so. That might make it 85%. That'll look pretty good. And so now we could see exactly where we are with in respect to time. So this is obviously everything to the left is the past, what has already happened. And now everything coming up here is the future. The other thing we could do too is the default grid is pretty hard to see. So I will go under, say, grid lines here, and on my vertical grid lines, I'm going to make those stand out a little bit more. Let's make those solid, perhaps a bit darker. That's a bit better. So now we could see these lines stand out a bit more. So if I'm looking, I could see that this line is at 12 p.m. noon on January 5th, the 6th, and so on. So a little bit easier to see exactly what's going on. So in a few minutes, you can see how we created something I think is pretty useful. Now, what we could do is we could look at, and because we created that relationship, we should see the cross-filtering work, and we could see exactly what has happened with some of this. We could see that for our most recent history has our stock on the Y has gone down quite a bit, and it's slowly starting to build itself back up. That's what we anticipate happening anyway, up until late tomorrow, and then going down. And likewise with, let's see what other stocks might look interesting. We could see our WHO stock is going to have a bit of a dip. And then which stock is this one? That's what, right? And so we'll click on that. You can see that this is going to have a similar trend and then really take a dive later on in January 7th or January 8th, roughly. So that's something we can watch. So this is a quick way that we can look at doing this. And what we would do also then is set this up to automatically refresh, say, every second. And then finally, from the Home tab, we could look to publish this report, perhaps set it up as a dashboard inside our portal. The next thing we'll do is we will switch back to our Fabric portal, and inside our Lakehouse, in this case, we might want to look at how we could create a bit more of a diagnostic dashboard. So with this in mind, we'll switch over to our SQL Analytics endpoint. This will let us create some views that we can create on top of the data. So in my Lakehouse, what I'm going to do is create a new SQL query and paste in a query that joins the stock prediction table and our minute aggregation table. The minute aggregation table, if we look at that, we could see that table is right here. And essentially it is a raw stock data that has been aggregated to the 1 minute level. The raw data that comes in has 1 second precision. So every second we're getting a new reading. And then we aggregate that to a 1 minute level here in the minute aggregation table to make it a little bit easier to work with, where we might not need that type of granularity to work with. And then we also have the hour table if we want to go to the hour level with that report. So now what this allows us to do is to look at all of this data that's here. So we can sort this. We could say order by predict time descending. Run that, and now we should see more recent values in that have just been created. So we could see that this is more recent. So we can look at then the Y hat, which is the predicted value of the tomorrow stock on 1/5. And then we can look at the last price for that 1 minute time block, the minimum price, and then the max price within that 1 minute. So we could see exactly what happened during that 1 minute time block. Really, the only thing I'm interested in here is the last price, because at the end of that minute, what was the price? And it was $895.94. I can compare that to our predicted value, which was $889. So we can build then a report that helps illustrate the effectiveness of our reporting. And so I'll go back to my Workspace and I'll look at all the reports, and I'll open up my predicted versus actual report that I've already built using that query. So I took that query, created another semantic model from it, and then added that report here. And we could see that this is the results of what we would look at. In fact, I think we're looking at tomorrow. I think it might have been the stock we were seeing there. And then we can grab a report that shows us how accurate our predictions were versus the actual. And the chart at the bottom shows this at a little bit more of a granular level if we'd like to see it, and then obviously a little bit more of a wide time frame. And so we'll see this data get updated. Obviously, every time we create a new prediction, we can see those jumps as the predictions are, the forecasts have changed. But we should see better accuracy over time as we have more data that we could use in building our model. So there you have it. You have two ways that we can use that data. One is more for diagnostic purposes of evaluating how accurate our model is. And then the first one is more from a real-time dashboard that might show us the current trend of a stock, but then also where we think that stock might be going. So we hope this information was useful. Again, all this code is downloadable. You can check it out in our lab. We have those links in the description. And you can download the notebooks and try this sample out for yourself. Thanks for watching.